Welcome to 5-Minute Math. This is Carrie Rhinehart. Today I'm going to be looking at graphing polynomials and characteristics. If you're following along in the text, this is from Algebra 2, Unit 2, Lesson 7. So first, let's talk about graphing polynomial functions. There's a few things you have to have when you graph. You need the roots. It would be nice to have the y-intercept. You don't have to have it, but it would be helpful. Okay. It's also good to know the end behavior, and they may not specifically tell you the end behavior, but you would be able to figure it out based on the information they give you. Sorry, I just misspelled end behavior. There we go. And then sometimes it's, you'll also know things like max and min, but these are the main things when you're graphing. So let's say, if you're following along in the book, let's say that I'm going to do example 2. I'm going to graph this function. Now another thing that is good to know is the multiplicity of the roots. Okay, multiplicity tells you if a root is going to go straight through, or if the function is going to go straight through at that root, if it's going to touch and go back the other way, which I'll say that's kiss. It kisses it, it touches it, and then goes right back the other way. It doesn't actually cross over. Or if it kind of dips down right before it goes through, but then actually does go through, which I'll call hugs. Now, if you have, so let me talk about that multiplicity. That tells you how many times is that root in there. So for example, the root or the factor x is in here, which means that's a root at 0 because x equals 0. Okay, x is by itself, so that's a root at 0. That is only in there once, so when it's got a multiplicity of 1, it just goes straight through. I'll just say through. And the same thing with x minus 3. If I set that equal to 0 and solve, I'd get a root at 3. That's a multiplicity of 1. It goes straight through. Now here, x plus 2, which would be a root at negative 2, okay, has an even, it's in there 2 times. So if you have an even multiplicity, okay, then there's going to be a vertex at that root, or it's going to kiss it. It's going to touch it and then go back the other way. Now, let's say you had an odd multiplicity. Let's say something was in there 3 times. That root was in there 3 times. Then it's going to hug at that root. That means it's going to kind of dip down a little bit, but then go through. So let's graph. I know the roots now, okay, because I have the factored form. So I've got a root at 0. I've got a root at positive 3, so right here, and a root at negative 2. So I know it's going to cross the x-axis at 0, 3, and negative 2. In this example, let's say it doesn't give us the y-intercept, but it's easy to find the y-intercept. So we found the roots. Again, we're at 0, 3, and negative 2. To find the y-intercept, you simply plug 0 in to the function for the x. So I'm going to plug 0 in for everywhere I see an x. So I end up with 0 times 0 minus 3 is negative 3. 0 plus 2 is 2, and that's squared. And if I multiply all this together, I end up with 0. So my y-intercept is at 0, or 0, 0. But if you have a root at 0 or an x-intercept at 0, that means your y-intercept will also be 0. So you really don't have to do it that way. But if it's not at 0, then you have to plug it in and find that out. Okay, the end behavior, you can figure this out by finding the degree. Okay, so I'm going to erase this. We have, this is x to the first, this is just to the first, and then that's squared. So if you add all this together, my degree is 4. Okay. If you have an even degree, okay, we'll talk about the degree here. Okay. We need to know the leading coefficient, even degree or odd degree. And you either have a positive leading coefficient or a negative leading coefficient. If it's an even degree, your arms are either both going up or they're both going down. If the leading coefficient's positive, then they're both going up. If the leading coefficient's negative, then they're both going down. Now, if you have an odd degree, then one arm, they're going in opposite directions. If the leading coefficient is positive, then the right arm is up. If the leading coefficient is negative, then the left arm is up. It looks like this. So in this case, our degree is 4, so it's even, and our leading coefficient is an understood positive 1. Okay, so our leading coefficient is positive and our degree is even, so we're here, both arms up. Okay, so both arms are going to go up. So I know from the the furthest to the left root, the root that's furthest to the left, in this case it's -2, I know that has to go up from there. And same thing on the one all the way to the right. I also know it's going to go straight through at 0 and it's going to go straight through at 3 because those are multiplicities of 1. So I know it's going straight through here, and I know it's going to go straight through at 0, but at -2, it's an even multiplicity. Remember, we talked about that a minute ago. The degree, it's in there 2 times, so it's an even multiplicity. So at this, it actually kisses, it touches and then comes back up. And then it just goes straight through 0, and it goes straight through 3, and both arms are pointed up.